Well, gentlemen, we are here at the beginning of yet another project. Okay, paperwork says, BBI. Bought this and it just don't work. All sorts of problems. Please, sir, work your magic. Also, can you call me with an estimate on cost? Thanks. You are appreciated, Mr. S. With all his contact information. Very neat and to the point. I called and I talked with Mr. S. And he says it just doesn't seem like it's working quite right and he wants us to add sideband to it. So, let's pull the screws out of this almost virginal Davemade. Davemade Moby, that is. That means it's made by Joe in the Carolinas. Kind of peeking through the grill, I can see that it's got 16 DO8s in it. So I kind of have an inkling, a clue, what might be going on the inside. But let's go take a look. Let's see how this is constructed. Yeah. Let the madness begin. Good fan. I've had a lot of luck with these little Sun-Ons. They put up with the RF punishment pretty good. I'm very pleased with them myself. Well, let's go take a look for you and me. Looks like typical Joe. Output relay is a little bit smaller than what I like to use, me personally. Combiners look okay. So what we got for output capacitance? Oh, let's see here. Two 500 puffers. So something happened in the last, I don't know, year or so, and we had to change our output capacitance based upon the transistor because the 16D08 changed. It just changed. So this is not right. He's got 1,000, what, 1,000 puff on the inputs. What? There's no tuning capacitor. There's solder for it, but no tuning capacitor. No capacitor here either, back at the relay. And like a 150 or a 140 here. That's too high. No tuning cap here. Shit. Okay, let's hook it up and let's run it and let's see what this looks like because I'm kind of interested to see what this looks like. And the guy says he's been using it, so it does make power. He goes, but man, there is something not right. Okay, I'll take a look at it. Okay, before I get into this next segment, I got to put a pre-preference out there and I got to explain to you where I'm coming at this from. If you are an art expert, you spend all day long looking at the fine minutia of different paintings, let's say, and you can tell who painted what and when they painted it and how they went about painting it just by looking at the art. Let us say for a minute that maybe my job is to look at these little boxes all day long and you start to get a taste of what each person, because everybody builds a little differently, right? Let's understand that first. Like when I look at a Fat Boy, I can tell by looking at it, one, the cabinet and the style of the cabinet and the style of the parts that construct it. That tells me that within this time frame, based off of the parts, there was this person, and this person working there making amplifiers. I can tell by looking at the box, usually if it was Dottie or if it was Tony or if it was whoever that put the amp together just by the characteristics of the way they built. I look at this and I go, this is a Joe Carolina's Moby amplifier, but this is not built by Joe. Joe's craftsmanship is different than what I see inside this box. Okay, now that we've got that all out of the way and we've established that this is just an observational thing and that in no way are we saying anything negative about anybody, I am here to just repair the piece of equipment that is not correct. I have not run this box yet. We're going to run it here in a minute. But I'm saying from an observational standpoint, there are some things in here that are not Joe's style. The length of the wires on the combiner, the way they're twisted, and how long they are. He's kind of weird in some sense, most of the time you won't even put a resistor back here on the combiner. Usually there's never one on the input. That's our first sign. Our other major sign is the heatsink. It is straight up and down and vertical. And when I look down through the slots in the back, it's also vertical. So that tells me whoever cut this heatsink, either one used a different bandsaw, or maybe Joe finally changed his bandsaw blade. But every single one I've ever seen come out of Joe's shop in the last like 5 or 6 years, one side of the heatsink is dovetailed down like a bunny slope, or it's convexed in on the opposite side. And it's from the bandsaw blade not being right, or the bandsaw not being right. So maybe they addressed that issue. So we can't really take that as a judgment. What we can do is look down in here and look at some of our solder work that is present on our positive wire and on our ground. I can tell just by the way that this wire was put in here that somebody took their iron and jammed it on here, slobbed snodder on it, and then just pulled it off and never bothered to reflow it. That's not a characteristic of Joe. Joe doesn't use these 5/8 or these 1/2-inch transformers, the 1/2 x 1/2 cores. He builds more with, my style of transformer, primarily, and he's still using them. How do I not have one of my own transformers just laying out here that I can grab on the fly? Oh, I do have an ICA one sitting over here. Joe uses these. This is our first big clue. This is the style of transformer that Joe uses, okay? Our next biggest clue is how the parts are assembled. Joe would never ever do something like this. Focus, focus, focus. There we go. What we're looking at is this leg on the 10 ohm resistor. You see this? See how that's 1.5 miles long? You see the solder drip that's hanging down here? These are characteristics that Joe doesn't do. And it's the same thing with the 120 puff capacitors on the output. Let's look at this from a top-down point of view. Joe doesn't build like this. So that made me go, this is new. There's someone new in the game. So I call a couple of my cohorts that live on that side of the planet, and I said, hey, I got myself a Davemade here that has got no tuning on the input network whatsoever. It's got 1,000 puffs on the input transformers. It's got like 490 plus 500 puff caps on the outputs. The transformers are wrong. And the way this box is laid out is in a configuration I've never seen Joe do. Did something change? And the answer immediately came back was yes. There apparently is a gentleman in Virginia that is taking on a little bit of the building responsibilities from Joe because he can't keep up. So he's working underneath Joe's name, but there's been some changes. So once again, I am not here to say anything negative about anybody. I am here to just do the repair. There are a couple things here that scare me, like this solder blob that's right here, down inside the case. It's literally laying up against the positive switch wire for the on and for the remote. But they are touching. So that means 100%, the 1,000 watts this box could make, potentially, goes right and literally is just the insulation thickness of the wire away from going completely kaflooey and making the box pop. So it's just amazing to me, just by looking, you can tell who built what and how it was built. Okay, less talking, more do. Let's go look at what we got going on here. Got ourselves a 1,000 watt slug in peak. Okay. Got 1,000 in average and a 5 watt slug in reverse. We are going to use the bench 2950 with the 5-watt slug in reverse between the radio and the 4-pill. We are down on 12 volts, as you can see right here. And the reason that we're on 12 volts is because I don't want to hit this thing very hard. I know that this thing is not going to work very well. It's impossible that it could. If it does, I'm going to be amazed. Amazed. So first, let's show you guys drive. Hello, 1, 2. All right. So you're putting about 19-20 watts in it. Let's go up here and let's see what the RF's ability is to pass through the amplifier. Hello, 1, 2. That's not too bad at all, actually. So now, hello, 1, 2, 1, 2. We'll flip our switch down because on these, the Joe box is down is on. Hello, 1, 2, 1, 2. Okay, we're making 200 watts of power. Hello, 1, 2. Oh boy. Let's go up here and let's look at this. Hello. Our output power is, hello, audio, 200 watts. It should be up in the area of 400 to 500. Let's get out the trusty, dusty old FLIR here. Let's take a look and see what's going on. We all know that this isn't right, so we're going to go ahead and we're just going to pray that all the transistors are still good. Hello. Okay. I will make sure to insert the picture showing that all 4 transistors heat up and run as they should. It's the circuitry around the transistors that is so far out of doodly-doobly-doo that it just no work. All right, let's do first things first. I want to clean up the solder work over here on the power wires. We are going to clean up some of this loveliness where the leads are almost touching. So 12 volt hot going through a 100 ohm resistor touching over here. I want to change this cap and this cap. We're definitely going to need to add some capacitance here. And yeah, we're going to see if we can get this to run. We're going to change these out too. Make them to something a little bit more electrically correct, like 1200 puff or something. So let me start into that and we'll check back in here in just a minute. Well, they're building a gallows outside my cell. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Okay. Let's go look at this. Turn the amplifier off. Hello, 1, 2, 1, 2, 1, 2. Okay. We're still on 12 volts. And we have the same amount of drive. Hello, 1, 2, 1, 2. It's looking pretty good. Let's come up here. Hello, 1, 2, 1, 2. These notes going in reverse as we go up in power. So let's reach down here and we'll charge our supercapacitors. Let's get this up here a little bit in voltage. Freaking 20,000 farad worth of super cap here. Not 20,000. What do I got underneath there? 2,000 farad. Okay. Hello, 1, 2, 1, 2. Hello, 1, 2, 1, 2. Just need 600 watts out of this thing. So let's Let's kind of pan out a little bit more and tilt on down here and show you everything I had to change to get this to work right. This is a lot of fun, I'm here to tell you. I went ahead and did a slight power wire upgrade to the inside of this thing. I moved the 12-volt positive lead from the end of the bus to the middle. That way both of these get the same amount of power. Power wire upgrade. This is a 330, 330. This is a 50. It's 180 puff. Otherwise, guess what? Exactly as you should build with the 2879 16D08. These worthless sacks of crap. I think these are type 67. I did a test on these and it was leaning itself more towards type 67. These were junk. So we replaced the 500 and the 480 capacitor here. Replaced it with 1200 puff. We got rid of the 1000 puff that they had on the input transformers. We replaced them with type 61 outputs, the 5/8, and metal clad capacitors. And then we did a metal clad capacitor out here for the output tune and got rid of the little 150 that was in there that will probably break the frick down, and that's the wrong capacitance value for these transistors these days. Yeah, I had to rewrap the output transformer, the combiner, because the way it was made, it was actually arcing when we finally got this thing to run right, as in get it up there around a couple hundred watts. It started arcing down here at the combiner because the way the combiner was wrapped, it was wrapped so shittily that there was too much insulation and it was arcing from the wire back to the ferrite bead. So we got all those little things taken care of, and those are little things. So let's come back on over here now. What we've done is we've switched radios. We're now on the Derail Striker 955. We have the average watts turned all the way down and the peak watts all the way up. Hello, 1, 2. Put about 125, 130 watts of drive into this little 4-pill. Hello, off in the corner. Hello, off in the corner. Boy, them average watts are pretty low. Let's reach up here and turn them average knob up. Hello, I'm a 400 bird. Turn it back down again. Hello, about 150 bird, 160 bird. So we're making 1300 watts now pretty reliably compared to when it came in here. It made 200. It's amazing what happens when you use the right parts and you slow down and you care about what you're doing. We're kind of working on a little bit of a budget here, just a little bit, so we're not getting too overly carried away with the modifications on the inside of this, but it did hop right up and come back to life. The input tune was, well, deplorable with 20 watts hitting it. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Same as before. It's a 5-watt slug in reverse. We're seeing about 1/4 of a watt swinging back. We've got 1 bar showing on the SWR bridge on the Striker. Hello, 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 hello. And that's laying up against the stop peg. So we'll go ahead, we'll turn this up to 2x. So once again, when the needle goes full over here to the right, it's 2000 watts and the 1000 watt mark. Now it's between the 40 and the 60. If we make it to 60, that means we're making 1200 watts of power. Hello. Just a little bit shy of 1200 watts of power out of a 4-pill. Otherwise, working as it should. So, God's miracle question that we're going to pose to the RF universe gods now is what happens when we put sideband bias in this? I don't know. I do know, but we're going to find out together. So let me go build that entire circuit here real quick. This thing is going to rail. Okay. Let's disconnect the Striker real quick. And let's start all the way over at the beginning. So, now we've got sideband bias on this thing. And we have sideband delay. let's see. 1X PEP. Let's go over here. We'll turn this radio on. 12 volts. Make sure amplifier's off. Amplifier's off. Hello, 1 2 1 2. Same amount of drive, about 20 whole watts. Okay. Hello, 1 2. About 20 whole watts. Hello. Hello. So it picked up 10 watts, 15 watts. Down here on 12 volts. Let's go ahead and reach down here. We'll turn on the super capacitor power supply system. And we'll put some voltage on the amplifier. Hello. Okay, so we could barely get to 600 before. Now we're cresting over 600. Hello. Like almost 700 watts with 20 watts of drive. Let's go ahead and back the camera out once again. Pan down. Get the coax for the striker. Tighten that down. Make sure the amplifier's off. Okay. Still on 1X, boys and girls. Hello, 1 2. All right. Hello, goodbye. Hello, goodbye. Let's look at the tune. Hello, 111. Hello, 111. It's a happy camper. So we're doing it well in excess of 1,000 watts. Out of a straight 4-pill with bias on it now. We're going to go up to 2X. Once again, right there's 1,000. That's 12, 14, 16. You get it. Y'all get it. Y'all watched a couple of these videos before, I'm sure. Hello. Hello. 1,200 plus with bias. So now it's all set up to talk sideband. Hello, 1 2. Hello, 1 2. I'm tickled. Perfectly happy. The other thing I did is I made it so the switch up was on the way it should be. Sideband is up. Put a sticker on the front. And I know the guys at Davemade have a hard time with labels. I covered up the Sharpie in and out and replaced it with a real label. You know, just cuz. Let's go ahead and I'm going to hook up the old fan. We're going to call it a win. This is the outro for this guy's repair. Gentlemen, my name is BBI. I want to say thanks. Thanks for following along. Big thanks to my Patreons. They're a major contributing driving force behind this channel over here every month. If you do feel like you've learned something from me, I've ever taught you something, or you just want to show support to the channel, please follow the instructions that follow the end of this video. I'll show you what to do. How about getting your name on the list? So on and so forth. Big shout out to MechMan, big shout out to Siglet, big shout out to Coaxial Dynamics Bird, and of course, the OG originals, you guys on YouTube. One more in the done bucket. 490 more to go. I'll see you guys. Click, click, click.